Good morning, everybody. Welcome to another video. Happy Monday. We are jumping into another one with relations and functions, and we're going to talk about x and y intercepts. So concept we should know from grade 9, and we're going to jump into it with a little bit more detail. So we'll jump into this lesson. You'll have a check for understanding to the end quizzes, and then we will be on our way. With that said, let's jump right in. Okay, page 413. Diving into x and y intercepts. Before we do, we got a quick recap of what we looked at the past couple of lessons. So it says a relation is a connection between two quantities for sure. A relation can be represented graphically by a set of ordered pairs. Okay, that's our x and y combo. Our coordinate pairs, or ordered pairs would be the technical term. Okay, the first component of the set is the x coordinate, also known as the input. And then we call that the independent variable. Okay, and then vice versa, the other one would be the y coordinate. That's the second component, right? It always goes x comma y. And those are called the dependent. X goes in, and then depending what x was, I get a y value. Okay, so there you go. That's what we kind of reviewed the past couple lessons, and then on the assignment Friday. Let's jump into a new concept. Exploring x and y intercepts. So I have 3 graphs here. Okay. It says list the coordinates of the points where each graph crosses the x-axis. Okay, well, I'm going to go ahead and kind of highlight the x-axis. That's the flat one. Okay. That would be the horizontal axis. Okay. And I'll do it in purple to maybe make it a little bit more obvious. So an x-intercept would be, well, when do I cross that line? That horizontal line. At what points do I cross that line? Well, for the first one, I cross it at 1 to -3. I go back 3, so my x value would be -3, and my y value would be 0. Okay, I didn't go up or down. I stayed on the x-axis. Graph 2, there's actually 2 moments, it looks like. -2, 0. And then 1 to +3, 0. So I actually have 2 x-intercepts for that graph. That's kind of interesting. And then the third one, I have 2 again. 1 there, 1 there. 1 to -4, 0. And then 1, 2, 3, +4, 0. So then the question becomes, well, what do all of those have in common? -3, 0, -2, 0, -4, 0, 4, 0, 3, 0.
0.0.
Well, all of them have y equal to 0. Okay, so the overall statement is for an x-intercept, okay, the y value has to equal 0, which makes sense when you think about it. A y value of 0 means I haven't gone up or down. Oh yeah, that would mean I stayed right on the x-axis. I am on the x-axis, and then I have to move up or down to get off of it. So if I didn't move up or down, I'm at an x-intercept. Okay, let's go now, and we're actually going to talk about the y-axis. So I'll go back. That's the vertical ones. So the ones I'm going to do in green here. Okay, and we're going to talk about when do we cross this axis now, or when do I have my y-intercepts. So there they are. Okay. Well, graph 1, it's just the one moment. It happens at y is equal to 5. So I didn't go side at all. I stayed right at the origin, and I only went up. So my x value is actually 0. My y value would be 5. Next one. Oh, it looks like I only crossed it one time, actually. So x is still 0. I didn't move side to side. I only went straight up to a y value of 6. So 0, 6. And then for graph 3, I have 2 as well. 4 and -4. 0, 4, 0, -4. So you look at all of those points and you say, well, what did those have in common? And I'll start the statement for a y-intercept. for a y-intercept, all of those values have an x value of 0. In order to stay on that y-axis, I can't have gone side-side at all. I just went up or down, so my x value is 0. Okay? And if we jump to the next page, okay, that's kind of what it outlines. So it says the x-intercept is the x-coordinate where it intercepts with the x-axis for sure, and it says the y-coordinate is 0. Conversely, the y-intercept is where we cross the y-axis, and the x-coordinate is 0. So down below, this is huge. Number 1 here, okay? Given an equation of a graph of a relation, if I want to determine an x-intercept, I set y is equal to 0 and I solve the rest. If I want to determine the y-intercept, I set x equal to 0 and then I solve the rest. So using algebra, I can actually find x and y-intercepts. And this is something where you're going to learn many, many different types of equations. We're going to look at all sorts of different things, not just in this course, but moving on. You can always do this, no matter how the equation looks, no matter how complicated, how simple, how new, how old, how weird, how simple. This is something we can always do. An x-intercept happens when y is equal to 0. A y-intercept happens when x is equal to 0. I can always do that. Okay? Number 2 says the equation of a graph can be written in different forms, all of which are equivalent. So it kind of says, yeah, hey, here's y equals 5/3 x plus 5. That's the first graph we actually looked at. Okay, that was the straight line. It could be also written like this: 3y equals 5x plus 15, or 5x minus 3y plus 15 equals 0. We're going to look at that later in a couple units, but it's kind of reemphasizing what I said. It actually doesn't matter what the equation looks like, or if it's been rearranged, or if it's been changed. I can still solve for the x and y intercepts in this same way. Okay, so let's do that. It says 3y equals 5x plus 15. Algebraically determine the values of the x-intercept and the y-intercept. Well, what I'm here to tell you is the x-intercept happens when y is equal to 0. So if I took that equation, and I normally wouldn't write it down again, I would just go, and I would say, well, the point that I'm looking for is when y is equal to 0. So instead of writing y, I'm going to write 0. I'm going to plug in the known value. So 3 times 0 equals 5x plus 15. 3 times 0 is 0. So what I have is a algebra problem. And you can say, well, I'm looking for the x value, I guess. I know y is 0. I'm looking for the x. I could solve algebraically. Get rid of that 15. Move that to the other side. Get it away from the x. Negative 15 equals 5x. Okay, well, now I'd go to divide. Great. And you'd get a value of negative 3 equals x. So in terms of a coordinate pair, you always write x comma y. Your x is negative 3. Your y is 0. That's the information I started with. And if I go back, I'll quickly just run back. This was graph 1. Hey, there's the x-intercept, negative 3, 0. So I could find it on a graph, okay, by just looking at it and locating it. I can also find it algebraically. We're hoping we get 0, 5 for the y-intercept, so let's see if we get that. Okay. The y-intercept happens when x is equal to 0. I know that. The y-intercept, I haven't moved left or right. My x value is 0. So again, I'll write it down just to write it down. But now I'm going to plug in x is 0. 3y equals 5 times 0 plus 15. And I'll simplify and then solve. 5 times 0 is 0. And then you'd say, well, 0 plus 15, that's really just 15. And then I just have one algebra step. Get the 3 away, get the y all on its own. Y is equal to 5. And hey, absolutely, my ordered pair, 0, 5. That's the same thing we actually did before. Okay, that's fantastic. All right, number 2 says the graph 3 is the equation x squared plus y squared equals 16. That's actually the circle. Okay, calculate the x-intercept and y-intercept of the graph and give your answers as ordered pairs. Okay, I'm going to invite you to do this ahead of me. So I would say this is a good opportunity to pause the video. And I would just say be careful because we got 2 x-intercepts and 2 y-intercepts when we looked at the graph. So keep that in mind as you solve. Okay, go, pause, do it ahead of me.
6 months later.
Okay, so hopefully you've gone ahead of me and solved at least a little bit. What I've done is I've partially solved both of these. So the x-intercept, I said that happens when y is equal to 0. So I took my original equation and I plugged in a y value of 0. So I get x squared plus 0 squared equals 16. Well, that's really x squared plus 0 equals 16, or the thing I'm trying to solve is x squared plus 16. So I need to solve that. Okay. Well, I look at that and I want x and I want just x on its own. And you say, well, it's x squared. So I would do the opposite of squared, which is to square root. Okay. And I'm going to do the square root of both sides. So I get x equals the square root of 16. And here's where I have to be really, really careful. And if you watch the additional or optional video on factoring, I actually touched on this as well. If I am introducing my own square root, there's something I have to consider. Okay, so I'm going to jump over here. I have it written out. The square root of 16, what you're asking yourself is, what times itself multiplies to 16? And I think the obvious answer is 4 times 4. But there's actually another answer, because negative 4 times negative 4 also equals 16. So in terms of this answer, it could be plus or minus 4. That's what that little sign means, plus 4 or minus 4. Well, the only reason I have to consider this is because I'm introducing my own square root. Okay? In the powers and roots unit that you did while you were still in class, we talked about a square root. If it's just a square root written, it means the positive one. If I wanted it to mean the negative option as well, it would have a negative sign out front. That's when it's written within a question already. If you bring in your own square root, if you introduce your own square root, you need to realize there's actually 2 options. Okay, so if I go back to here, I would actually be saying this is plus or minus the square root of 16. So x equals plus or minus 4. Okay, and I think this one's easy to notice because it was a circle and we already saw the 2 options. It was 4 comma 0 or negative 4 comma 0. Okay, and if I did the y-intercept, okay, I've already got that started and we'll quickly finish it. Well, that happens when x is 0, so I plug that in. I end up down here with y squared equals 16. And if I want to solve that, I could take the square root of both sides. But remembering, if I introduce my own square root, I need to consider that it could have been the positive version or could have been the negative version. There are 2 things that multiply by themselves to 16. And those are my answers. X is 0, and I could have a y value of 4, or x is 0, and I could have a y value of negative 4. Okay, so that is solving x-intercepts and y-intercepts algebraically. That's something you can do all the time. An x-intercept happens when y is 0. A y-intercept happens when x is 0. Okay, that's crucial, an algebraic skill to find the exact answers for my x and y-intercepts. All right, let's move on. We've got one question left. It's a bit of a doozy, but we'll work through it. So, what is it? Lisa purchases a new car for $20,000. The value of the car can be represented by the formula V for value equals 20,000 minus 1,250 T, where V is the value of the car in dollars and T is the age of the car in years. So Lisa buys this car, drives it off the lot, and the moment after that, it starts to lose value. Right? It doesn't stay at 20,000 forever. It says we're going by years, but realistically, it could go by month even. But by the year, the price is going to go down and down and down and down. Okay. So it says, complete the table of values and plot the ordered pairs on the grid. Okay. It tells me a couple inputs. So I'll just go to the side to do this. V equals T value of 0, so 20,000 minus 1,250 times 0. Well, that would be 20,000 minus 0, or, oops, I forgot a 0, 20,000. Okay, 20, got to write really small. So that's my first ordered pair. 0, 20,000, and I can put that right on my grid. And then you'd say, okay, well, now I'm going to plug in 2. V equals 20,000 minus 1250 times 2. So V equals, or your value equals 20,000 minus 1250 times 2 is 2,500. And I subtract that from 20,000 and I get 17,500. Okay, there's my second point. After 2 years, this car is only worth $17,500. Oh, I have an extra 0 on that one. There we go. Okay, great. And I could actually plot that as well. So I'd go, gotta zoom out. 2 would be, okay, every tick is worth 1. And then I'm going up to 17,500. Well, that would be right in the middle of 17,000 and 18,000. There we go. That's my second point. Okay, let's quickly do the next ones. V equals 20,000 minus 1250 times 4 years now. So we're not going every year. We're kind of skipping. We're trying to build this line, spread it out a little bit. We'll go from there. So that would be 20,000 minus 5,000. Okay, 1250 times 4 is 5,000. Or my value is now only $15,000. 1, 2, 3. Okay, and we'll plot that one. 4, 15,000. I think that's right there. And the last one, we're running out of space. 20,000 minus 1250 times 6. So 20,000 minus 1250 times 6 is 7,500 for a value of 12,500. Okay. 6, 12,500. All right, and I'll plot that one. That would be right in the middle of 12,000 and 13,000. Right there. Okay, great. So that's A. I completed the table of values and I plotted them on the grid. And then it says connect the points with a straight line and extend the line. Okay, so this is where you get out your ruler, or you can use the side of your calculator or whatever. And we are going to do our best to draw a straight line through these. Not great, but I'll do my best. Okay, try to fix it. Yeah, we'll call that good enough. Okay. Oh, what did I do? What did I do? What did I do? What did I do? All right, I'm calling that good. Calling that good right there. Okay. All right, it's gonna work. Okay. So I have my straight line. It says, what does the ordered pair 0, $20,000 represent? Okay, that is right up at the top. That is 0 in terms of years, $20,000 in terms of value. Well, that would be how much I paid when I bought this vehicle, right? I walked in, $20,000 vehicle, 0 years on it. It is worth $20,000. The second I walk out the door, it's going down in value. So that would be the original value or the original cost, okay? Or the selling price, I think, is a good way to talk about it, okay? And yeah, maybe there's a little bit more nuance to it where if you're at a car dealership, they're probably selling it for, maybe more than it's actually worth and all of that. But let's just call that the selling price, okay? And then it says, use the graph to estimate the t-intercept, okay? So that would be like my x-axis, okay, but it's my t-axis. That's this point right here. And I bet if you did it with a ruler, you're probably going to get a different number than me here, just because you're a bit more accurate. And this is an estimate, right? We're estimating. Well, to me, that value is 15, 16, 17. Let's just call it 17.5. Okay. 17.5 comma 0. And that's probably not accurate, right? I think my line is maybe not perfectly lined up with everything. If I were to do it maybe with an equation, it could be more accurate, but that's okay. All right. Well, what does that represent? Well, that would be the t value of 17.5, so 17.5 years, and 0 is the value. So what that represents is, when is this car absolutely worthless? Okay. When does this car have absolutely zero value? I couldn't even sell it for scraps. I couldn't sell it for anything. The value is nothing.
Whoa! This is worthless.
It's less than worthless, my boy.
Started at a value of 20,000, and this is when my value goes all the way down to nothing. Okay. D. Use the graph to estimate the values after 3 years, 10 years, 14 years. Okay, so this is where I'd get my ruler out again, and I would go 3 years. Here it is. And I would do this with a ruler, and I'm marking my way up that line, trying to find what point on the graph has a value of 3 years. Oh, it's right here. 16,000. $16,000. 10 years, I do the same thing. Whoops. I start at 10. I mark my way up the graph, and I would do this with a ruler if I had one. Find that point on the graph, and then I can go over horizontally right in the middle of 8,000 and 9,000. So that would be 8,500. Okay. And 14 years. This one's lower. I got to do less drawing. Let's call it there. And then I move over horizontally. I think it's 4,000. Okay. And those are technically estimates. If I'm using a graph that I drew, it's all based on the fact that my graph is actually correct or my graph is actually accurate. So those would be estimates. If I was really, really accurate, I would have confidence that they were correct. If I was maybe doing this with a piece of paper and a real ruler and pencil, I would be more confident. But maybe not so much here, just where my lines don't always end up where I want them. Okay. It says use the formula to verify D2. Okay, so that's really, I'm taking a t value of 10 and I'm plugging it into the original formula, the value formula that we did over and over again. V equals 20,000 minus 1250 times your t value of 10, which would be 20,000 minus 12,500. And just move my answer up here, type that into your calculator. Oh, it does work. Oh, I have V equals twice. Yeah, I actually do get the same answer. V equals 8,500. So for those examples, my graph was accurate enough, or maybe I was just lazy and went to the nearest, big number or nearest line instead of guessing 8,475 or something like that. But it worked. Okay, so using the formula would be an exact answer, whereas using the estimate and using my graph, maybe not exact. Okay, let's move on. I got a couple more questions, or a few more questions. Use the graph to estimate when the car will be worth $5,000. Okay, $5,000. Well, that's actually a value. That's over on the y-axis. And then I would go horizontally to find that point. Oh, there it is. And I could go vertically down. Looks like that happens after 13 years. Okay. And then the next one says half of the purchase price. Well, if it was $20,000 when I purchased it, the selling price, half of that would be $10,000. So I go to 10,000. I go over to the graph, see where that value happens. Not perfectly lined up. So I'm going to go down right in the middle of these two values. Looks like it's in the middle of 6, 7, 8, and 9. So I don't know. Let's guess 8.5. And might be perfect. Honestly, it might be. Might be an estimate. It might actually be 8.4 or 8.6 or whatever. I might not be perfect on that. And that's actually what we're going to check in G. There's not a lot of space for it. That's okay. It says, use the formula to verify that. Well, just a reminder, here's the formula. V equals 20,000 minus 1250t. I'm actually trying to find t, and I have the V. I have $10,000. So this is where I plug in the value that I have. I have 10,000. That's V equals 20,000 minus 1250t. And this is what I'm going to solve. Okay, I actually have to do some algebra. So I'm going to put this in a new tab so that I have more space. Sometimes the workbook just, isn't enough. Okay, minus 1250t. Okay, so I've got multiplying by negative 1250, and I've got this addition of 20,000. The way to get rid of add 20,000 would be to subtract 20,000. And what I do to one side, I do to the other. Okay, so I get negative 10,000 equals negative 1250t. And now I can get rid of that multiplication by dividing. Divide by negative 1,250. What I do to one side, I do to the other. And I get a value, if I type that into my calculator, 10,000 divided by 1,250, I get 8. There you go. So I'll jump back and I'll just write that in here. 8 is equal to t. So my estimate was actually a little bit off. Okay, I was supposed to get 8 and I got 8.5. That's where the graph, if I build it, is probably not as accurate as just doing it with some algebra and solving things perfectly. Okay, let's complete the final statements here. The original value of the car is $20,000. It depreciates by value $1,250 every year until it has no value after, what did we say, 17.5 years. Yeah, that might be accurate, that might not. Okay, somewhere between 17 and 18. Okay, and there you go. So the x-intercept in this one tells me when is the car worth nothing. The y-intercept told me, hey, what did this car kind of start as in terms of value? And there's all sorts of stuff I can talk about within. So that's a pretty hefty question. And that is it. Okay, that's it for today. A little comment. I think I've already said this. Okay, in this lesson, using algebra gave us the exact value, and then graphs gave us an estimate because I was making the graphs. Later in this unit, and quite often, we're going to learn how to use our graphing calculator to tell us exact values. Okay, so if I'm making a graph by hand, it's probably not super accurate, but our calculator can do it perfectly. And we'll be able to take advantage of that. Okay. I'll skip that over. Okay, there you go. There's your homework. 416, 1 ACA, 2 CAC, 3 AC, 4, and 5. Okay, guys, that's it for today. Another one in the books, talking about X and Y intercepts. So make sure to do the homework. Make sure to do the check for understanding. As always, send me some questions in the Google form. Set up a one-on-one appointment where we can get together to go through some things. And we'll work through this and we'll get set. So there you go. Smash the like button. Hit subscribe. That's it. Have a fantastic day.